Yazıları biraz engelli.
All right. Well, last time we were talking about annihilator. So let's continue with this. So we continue to annihilators. Well, remember that annihilator is an operator. Let me recall this. Annihilator LD, which is like a polynomial, but it's a differential operator. D to the, let's write like this, an d to the n plus an minus 1 d to the n minus 1. Here d is the differential operator. It basically takes the derivative, okay? A1 d, okay, plus A0. Okay, this annihilator is, it's an operator and it acts on functions. So when you act this to a function like this, f of t, you get 0, okay? So it satisfies the following. First, this, and the second, here, the degree n is the smallest, okay? So n is the smallest such numbers, such positive numbers. We had some examples of annihilators. Well, let me recall some of those. Well, for instance, the basic ones, d minus lambda times e to the lambda t is equal to 0. That means d minus lambda is the annihilator of e to the lambda t. Another one, d minus lambda to the k plus 1 times t to the k e to the lambda t is also 0, and here k is the smallest. Again, this tells you d minus lambda to the k plus 1 is the annihilator of the function t to the k times e to the lambda t. We did all this last time. Another example was cosine and sine. well, we had d square plus a square. When you apply this operator to cosine at, you get 0. And similarly for sine at, it's 0. Okay, we get that. And right, so we stop at this point. Okay, so let's talk about more with annihilators. Well, effect, maybe let's write this as effect. For more complicated functions, how do you find the annihilator? Well, if L1d and L2d, let's say these are annihilators of two different functions, are the annihilators of B1t and B2t, then the annihilator of A times B1t plus, here A and B are constants, okay, B times B2t. What is the annihilator of this in terms of L1 and L2? Do you have any guess? Well, this is the least common multiple of L1 and L2. Okay, is the least common multiple of L1 and L2. Let me maybe let's see, L1d and L2d. Okay. Let me do an example and you'll understand this better. So let us look at the annihilator of this function b of t, which is e to the minus 2t plus t squared e to the minus 2t plus cosine root 3t plus t. Okay, so what is the annihilator of this function? Well, let's find the annihilator of each of the function in this bt here. For instance, the annihilator of e to the minus 2t. We know this is what? D plus 2, right? And similarly, annihilator of t squared times e to the minus 2t. Now remember, when you multiply with t to the k, you take the k plus 1 power. So it's going to be d plus 2 to the 3, right? And what about cosine root 3t? This is, as in this example here, it's d squared plus root 3 square, which is d squared plus 3, okay? And the annihilator of the last function t. Well, how do you kill t? If you differentiate once, you get 1, and twice you get 0. That means it is d squared. So what is the least common multiple of these functions here, these operators here? Well, you see here d plus 2 and d plus 2 to the cube, they are common. D plus 2 is common here. So the least common multiple is the annihilator, and let's write the annihilator of b of t is d plus 2 cube times d square plus 3 times d square, right? Yani burada en küçük ortak katı alıyoruz. Least common multiple demek o demek değil mi? En küçük ortak katını alıyoruz bunları. Least common multiple here gives you the annihilator of the combinations of these functions, which is bt. Okay. Any question with this example? Well, that means if you apply this operator, d plus 2 cube times blah blah, if you apply this operator to b of t will vanish. We have more than that, and this is the smallest degree operator satisfying this vanishing property. Okay. Right. So there's one question: do we need to memorize it? At least you need to memorize this 4 of them. Okay. Then you can derive other ones from this ones. All right. Let me do another example. So let us look at this function b of t e to the at cosine bt. Let's find the annihilator of this function. Well, we can rewrite this and then try to find the annihilator. So you can write cosine bt. What is cosine bt? Cosine bt is, it's the real part of e to the I bt. So you can think of this like this part only, e to the I bt plus e to the minus I bt over 2. It gives you cosine bt. So when you multiply with e to the at, you will end up with e to the, or let's write like this, over 2 e to the a plus ib t plus e to the a minus ib t. Okay, then it gives you b of t. We write like this because we know the annihilator of e to the a plus I b t, right? So the annihilator for this one, let's call it L1d. It's d minus a plus bi, right? This is the annihilator of the first function. The other function here, the annihilator of this one, d minus a minus bi. So as in the previous remark, the annihilator of the sum will be basically the least common multiple of this two, which is the product of this two, right? You multiply this two to find the least common multiple. Well, let's write the annihilator here. which is in this case L1D times L2D. So L1D times L2D, which is D minus A minus BI times D minus A plus BI. And this is nothing but, you can do this yourself, D square minus 2AD plus A square plus B square, okay? Any question with this example?
Hocam bu ifadede önce çarpımı böyle toplam şeklinde yazmamız gerekiyordu ki toplamların böyle annihilator'ı çarpım şeklinde yazabilelim. Değil mi?
Evet, evet,
Yani
aynen öyle.
çarpım her türlü toplam şeklinde olması lazım.
Aslında şey yapmaya çalıştık burada, yani bir annihilator'ını bildiğimiz fonksiyonlar cinsinden yazdık önce. Çünkü değil mi, E üzeri bir şeyin annihilator'ını biliyoruz. Dolayısıyla dediğim gibi o şeyi kullandık. Toplamda en küçük ortak katı, least common multiple, right? So the annihilator of the sum is basically the least common multiple of each operators. So we get that. Güzel. All right, let's continue. So now let's, well, basically you need to know all this basic annihilators and that's it. Once you know the basic annihilators like this, you can solve many differential equations. So let's do this. So this is the method of it's called method of undetermined coefficients. Via annihilators. Okay, so there is a question. I didn't get how we change cosine BT. Well, cosine BT is, let me write the formula here, e to the IT is cosine T plus sine I times sine T, right? And e to the minus IT is cosine T minus I sine T. So if you sum up this two, you will get cosine T is e to the IT plus e to the minus IT over 2, okay? So we use this formula. Is that all right? All right, good. Okay, let's continue with this. How do we solve the equations with annihilators? So what we do is, let's consider, so we consider the ODE differential equation in this form. Well, you remember any linear ODE can be written as LDY is equal to B of T, right? So we will solve this system, this equation. So let's call it star here. So to solve star, what we do is we find the annihilator of B of T. Find the annihilator B of T of annihilator, sorry. Let's call it MD of B of t. This is the first step, and we know how to deal with this. Gökçe, I couldn't get your question. Can I be any
I'm
coefficient?
sorry, I was not there in the first 5 minutes or so. So in the cos t equals e to the it plus e to the I minus t, can I be any coefficient,
okay.
or I is a like I don't know, anything else?
Real number. So it's like e to the I t here. T is any real number, okay? Any real number. In that case, this is cosine t plus I times sine t, okay? And e to the minus it is basically, you replace t by minus t, but sine is an odd function, so it becomes like this, minus I sine t, okay?
Okay,
So
but
this
what about I? Is I a coefficient?
I is the imaginary number, so it's the
Okay, I'm
imaginary
sorry.
number
I'm sorry.
which gives you minus 1, okay?
Okay, thank you so much.
All right, good. All right, so we find the annihilator of B of t, and next we apply this annihilator to the equation. So apply MD to star. And what you get is basically MD LD phi is equal to MD B of t, okay? Well, MD B of t is what? It's 0 because it is the annihilator of B, right? So this is basically 0 because MD is the annihilator of B. So we get a homogeneous equation. Now let's call this as double star. By applying the annihilator, we get a homogeneous equation. Then solve the homogeneous equation, double star. Homogeneous means right hand side is 0. On the left hand side, you have a differential equation, differential operators, and this gives you differential equation. Well, the thing is, when you solve this, you will get some solutions, and not all the solutions of the second equation will give you the solutions of the first equation. Some of them will not be the solutions, so we will eliminate those. So not all solutions to double star are the solutions of star. So what you need to do is you plug in the solutions from second equation into the first equation, okay? So to find the solutions of the first one, we plug the solutions of second equation into the first one, okay? And we eliminate some of the coefficients. Well, this looks like long, but it's not, okay? The difficult part is here to find the annihilators. After that, it's gonna be very simple. Let's do some examples. So what you do here is basically you solve a non-homogeneous equation by reducing equation into a homogeneous equation. We know how to deal with homogeneous equations, right? So let's do this. Second derivative minus y is equal to e to the 2t. Of course, you can solve it. You can solve this by guessing the particular solution like we did earlier. This is one way. Here, we will solve it using annihilator. Okay, using annihilator. So what is the annihilator of e to the 2t? Or maybe let's write this here, the equation in this form, d squared minus 1 y is equal to e to the 2t, right? You can also write this here as this one. They are the same, right? Instead of y double prime minus y, we use differential operator, d squared minus 1y. They are the same. Then what is the annihilator of e to the 2t? Annihilator of e to the 2t is d minus 2. So you apply both sides d minus 2, you get the following: d minus 2 times d squared minus 1 y is equal to, when you apply d minus 2 to the right hand side, you will get 0. But let's write it for the first time. This one, it's 0. Okay. So basically, you get an homogeneous equation, and we solve this homogeneous equation. So what are the solutions of homogeneous equation here? Well, the roots are 2 plus 1 minus 1, right? So this is nothing but, if you want to write down this in differential form, you don't need to, but it's like y it's not easy to write down, but you don't need to do that. So this general solution here, two, let's call here this double star, and let's call it here, this is star, okay? Double star. Well, the roots are 2 and plus minus 1. Okay, how do we get this? There is one question. D squared minus y, d squared minus 1 is equal to this. Well, d squared minus 1 means what? D squared minus 1. Y means you apply d squared to y minus y, okay? But d squared means y double prime, okay? Clear? D is the differential operator. We simply replace a derivative by d, okay? Well, so we get the solution here, C1 e to the, so what are the roots here? Roots are roots of the characteristic equation. Maybe let's write it like that. Roots of the characteristic equation. Characteristic equation. It's 2 and plus minus 1. This will give you the general solution to the homogeneous equation. So it's going to be C1 times e to the 2t plus C2 times e to the t plus C3 times e to the minus t. But remember, not all solutions are the solutions of the first equation, so we will plug this back into the first one. So plug in to star to find which ones are the real solutions of the first equation, the original equation. Okay, so basically the first equation is d squared minus 1 of c1 e to the 2t plus c2 e to the t plus c3 e to the minus t. It must be equal to e to the 2t. So let's see what we get from this. When you apply d squared minus 1 to this one, d squared minus 1, when you apply this operator here to this one here, you will get 0 because e to the t and e to the minus t, these are the solutions of the homogeneous equation. So you will get 0 from this, okay? The only term remains here when you apply this one to the e to the 2t. So basically, the whole thing on the left-hand side will be this will be 0, and the whole thing will be c1 times d squared minus 1 e to the 2t, okay? But what is this? This is basically c1 times, what is d squared minus 1 times e to the 2t? D squared means you differentiate twice, okay? So you differentiate e to the t twice, and you will get basically 4 e to the 2t, right? If you differentiate e to the t 2t twice, you will get this minus e to the 2t. And this is equal to, from this here, e to the 2t, which implies basically c1 is equal to, here this is nothing but 3 times e to the 2t. So c1 is equal to 1 over 3, okay? Now let's return to the solution here. So we get that from this, c1 is 1 over 3. So the general solution to the original equation star is y of t is equal to, well, c1 is 1 over 3. 1 over 3 e to the 2t plus c2 e to the t plus c3 e to the minus t, okay? Well, you can compare this with the previous method where we find a particular solution and homogeneous solution. Particular solution was you guess the particular solution, and this will be the particular solution, okay? So this is like yp as in the previous method, and this part solves the homogeneous equation, okay? You could also use that method, guessing the particular solution. Okay. Any question with this?
Hocam aslında general solution'dan önce d eksi 2 d kare eksi 1 y denklemini nereden bulduğumuzu tekrar anlatabilir misiniz?
D kare eksi 1 denklemini nereden mi bulduk? Şunu mu diyorsun?
D Birazcık daha altta. Annihilator'dan hemen sonra yazdığımız denklem.
Duyamadım. Bir daha söyler misin?
Annihilator'dan hemen sonra yazdığımız denklem. D eksi 2, D kare eksi 1, Y eşittir diye giden denklem.
Evet.
Bu denklemi nereden bulduk acaba?
Şunu mu diyorsun?
Evet hocam.
Burada d kare eksi, şimdi şunu biliyoruz değil mi? Bu zaten bu demek.
Okey.
Bu ikisi aynı.
Hı hı.
E üzeri 2t'nin annihilator'ı d eksi 2 ya. Amacımız onu yok etmek. O yüzden iki tarafı d eksi 2 uyguladım.
Okey. Tamam.
Oldu mu?
Evet.
Amaç burada sağ tarafı yok etmek. We would like to kill the right hand side here, and right hand side we have e to the 2t. So the annihilator of e to the 2t is d minus 2. So we apply d minus 2 to both sides, okay?
Evet. Teşekkürler.
Okay, cool. There is one more question after the general solution. Well, here, first we find the general solution of the homogeneous equation when the right-hand side is 0, okay? This is the general solution of the homogeneous equation. But it's not necessarily the solution of the non-homogeneous equation, right? Like this. Let me explain maybe with this argument. So let's say x minus 1 is equal to 0. So this is an equation. And if you multiply this with x plus 1, you get x squared minus 1 is equal to 0. Right? From here to here, we multiply with x plus 1. What are the solutions here? X is equal to 1 or minus 1. But which one is the solution of the first equation? So this is the first equation, and this is the second equation, okay? To find the solution of the first equation, we take this and plug into the first equation. If it satisfies the equation, then it's the solution. You take this and put it here, and this is not a solution, right? So it's like that. Anlaşıldı mı? Şimdi yeni bir denklem elde ettik. O denklemin tüm çözümleri ilk denklemin çözümü olmak zorunda değil. Hangileri çözümü diye bakıyoruz. O yüzden aldık onu. Değil mi? Şimdi burada ilk çözümde şöyle genel bir çözüm elde ettik. Homogeneous denklem için, ama bunlar non-homogeneous denklemleri olmak zorunda değil. Bazıları çözümleri. Hangileri çözümleri diye bakmak için bunu aldık. İlk denklemde yerine koyduk. İlk denklem neydi? D kare eksi 1'di ilk denklem. İlk denklemde yerine koyunca ilk denklem zaten şu kısım ilk denklemin çözümü. Dolayısıyla oradan 0 gelecek. Sadece diğer kısım kalacak falan. Oradan da C1'i bulduk. Any other question, comment?
Yes, can I ask a question?
Sure.
When we multiplied d square minus 1 with C2 and C3, there was 0. I didn't understand why there is a 0.
Because this part here, C2 and C3 part, it's the solution of the homogeneous equation. Homogeneous equation is basically d square minus 1, y is equal to 0, right? So this here, e to the 2t and e to the minus, e to the t and e to the minus t. Let me explain here. We had this, right? D square minus 1, C1, e to the t plus c2 e to the minus t. Well, what are the roots here? Roots are plus minus 1, right? And here we have minus 1. So d square minus 1y is equal to 0. What is this? This is the equation y double prime minus y is equal to 0, right? And the solutions are what? Y is equal to c1 e to the t plus c2 e to the minus t. That means if you plug this back into the equation here, you will get 0. Clear now?
Yes, thank you.
All right, good. Any other question?
Hocam yine o çarpma işlemini yaptığımız kısımda bu C2 ile C3'ler gidiyor ve C1 böyle eşitlik oluyor. Yani D2
Evet.
eksi. Şimdi burası bunu şey yaptık. Sol tarafı sağ tarafta açmış bulunduk, değil mi?
Evet.
Tamam.
Evet.
Tamam hocam.
Yani orada C2, C3'lü kısım gidiyor. D kare eksi 1 onu yok ediyor. Sadece C1'li kısım kalıyor.
Tamam. Eşitlikte de aç. Tamam, teşekkür ederim.
Orada türev aldık. E üzeri 2t'nin 2 kere türevini aldık. Sonra kendisini çıkarttık. 3 çarpı e üzeri 2t geldi.
Tamamdır
Olur
hocam.
mu?
Teşekkürler. Aynen.
All right, let's give a break here for let's say 15 minutes until 11:40.